All right, let's get going. So we are back, data structures for Monday, January 27th. So welcome back. Hope you guys had a good weekend. Here's what we're going to do today. We're going to do a little bit more on the homework one, what I'm calling postmortem. So it's in. Hopefully you guys all did it. If for some reason you didn't get a grade, or you think your grade is incorrect or graded improperly or something, please let me know. Just email me, or you can put something on Piazza if you'd like, or you can just email me. But there will be grading mistakes. So for what it's worth, when we find a mistake, we'll try to rectify it such that it makes the most sense from a fairness perspective. So if you got a grade back and didn't like it or whatever, email me and we can talk about it. If you didn't submit your homework, well, it's kind of too late, but talk to me anyway. I know a couple people just joined the class, and we did have one assignment already due. So please chat with me if you haven't submitted the assignment yet, and we'll see if we can figure something out. OK. We'll also talk about Lab 1, which actually starts this week. On the same note, you should have gotten an email from Bruce saying, hey, you've been assigned to this lab group. If you didn't get that email, stick around right after class, and we'll talk to Bruce, and we will figure it out. I apologize to those of you who didn't get your first or second choice. We tried to do the best we could. It was this big process where we tried to organize everything, and we tried to do the best we could. If for some reason you can't go to the lab that you are assigned to, then again, stay after class. We'll figure it out, and we'll do it. Bruce? Oh, and you can change online. So Bruce? Yeah, go to the lab assignment page and then change your lab. You can actually do it. If a lab's full, you can't change into it. But then if somebody comes out, it becomes unfull again. And Bruce has this great script all set up to do that. So you can still do that. But if you haven't gotten any email at all, then you probably want to stay after class, and we'll chat about that. OK, then we'll talk about arrays just a little bit more and inserting. And then we'll go into the big part of the lesson here. I'm going to try something I've never tried before, and hopefully it'll work. It's going to involve a couple of volunteers. So we'll see how that goes. And we'll get into that. OK, any questions before we go into the homework one post-mortem? OK. All right. So again, as I said the other day, overall, homework one was very good. You guys did great on it. There were a couple common mistakes. So a number of you, for some reason, now that we know about assert, hopefully this won't happen in the future, but a lot of you guys actually checked for errors. And then, like, so we had an assertion that said that the width and the height had to be greater than 0. So you checked that. You said, if width and height are greater than 0, set the width, set the height, good to go. But if it wasn't greater than 0, some of you guys just didn't set anything, and your program continued to run, right? And the problem with that is then now you've got undefined behavior, so completely undefined behavior. You haven't set anything, and your program didn't actually give any errors, or, well, it might have given an error even, but a lot of people have even continued to try to create rectangles with no values. So don't do that. If you're going to have an error, either stop the program, or in our class, you're just going to stop the program. But if you're writing a real program, you want to actually handle that error in a way that makes sense. OK. Bruce's autograder. Look, it doesn't have artificial intelligence. OK, so a lot of people got their output was different than what the autograder's output thought the output should be. Right? Well, why was that the case? Well, some people put an extra trailing space. Some people they actually asked for input instead of just accepting input, right? And that actually ends up being the output to the program. And the autograder goes, I don't know what this is. This isn't right. It's not an artificial intelligence thing. And you might think, hey, that's kind of pedantic. And what's the point of actually making it exact except for the autograding? Well, look, when computers talk to each other, which is basically what's going on here, Bruce's script is talking to your program and interfacing. And that interface has to be perfect. Okay, when you go to Amazon.com and you start and your computer talks to Amazon's servers, right? They have an interface that they know your computer's going to say X, Y, and Z, and it's going to expect, the Amazon servers are going to expect exactly X, Y, and Z with no extra spaces and no trailing this and that. I mean, you can certainly get around things like extra spaces and things, but you don't want to have to, and interfaces are going to be designed generally to need exact information. How do you guarantee that with like the craziness of messages being passed back and forth between lots of computers? You do error checking and so forth. But again, it needs exact output. So we're going to expect that your output will fit exactly what the output that we've asked for in the assignments are. If you're not sure what that means, put something on Piazza, say, I don't exactly know. Do you want this to have an extra return? We'll try to be very specific about it. But if your program doesn't, it'll just fail the autograder, and then it'll be a little more pain to grade. Questions on that? OK. All right, a couple other things. Now, this was not an error necessarily, just a slight different way of thinking about things, and a different way of actually creating your variables. What we were expecting is for you guys to do something like this, rectangle R1. Now remember, R1 is your class, OK? And when you declare a rectangle R1 like this, what it does is it actually calls your default constructor and constructs a rectangle for you with 1, 1 in our case. And this is what that actually does. And what this is called is automatic storage duration, which means that the compiler sets it all up beforehand, and it's got the storage in that case. It's a little odd that it does that, but that's the way this does. So if you said rectangle R1, comma R2, which some of you did, what you did was you created a second rectangle with a width of 1 and a height of 1, and then some of you actually went and recreated that rectangle later. That was an error. You could also go and do the set width and set length, and you could do it that way, but you don't necessarily need to. OK, so what you probably should have done is later on, once you had the input, have rectangle R2 with the constructor that you want. OK, that's what we were expecting. If you didn't do it that way, that's OK. There were different ways to interpret some of these things. The other way that some people did was they actually created a pointer to R1. OK, and then this just declares the pointer. This doesn't actually declare the space for your class. It just declares a pointer and says, at some point, I'm going to point to a rectangle. OK. And then they said R1 equals new rectangle with the default constructor. And this is a dynamic solution where it's actually put in a completely different place in memory. And you technically should use a delete on it if you're going to be deleting them later. In this program, obviously, you wouldn't need to. OK, we're going to talk about the differences of why we do this a little bit later. And in fact, today, when we do linked lists, we're going to see a lot of this versus this. But just keep in mind, this is a slightly different construct, and it's a different way of creating your rectangle. This doesn't create a rectangle. This one does. This also creates a rectangle. OK? Questions on that? All right. And then finally, so a couple people, so one person in particular, I won't give up any names or anything. OK, actually, a couple people did this. Used the absolute value function, which was great. This was for the part of the assignment that you needed to do the comparison of floats, and you're going to compare it to epsilon. What they did was they used the absolute value function, but actually they used the wrong one. And why are there different absolute value functions? Well, it depends on which library you're using. If you happen to use, let me see, I forget which library it is, C standard lib, I think it is. If you happen to use that library and tried the absolute value function like this, it's expecting integers. OK? And what happens is, if you've got two floating point values and you run them through, you subtract and run them through absolute value, you end up with an integer. And that may not be what you're expecting for your result. OK, fine. The compiler actually didn't flag that as a warning for some reason. Hopefully in the future it will. But I can't exactly figure out why it didn't do that. But it didn't flag that as a warning, and it just let it go. The problem is, the people that did this didn't check their code against values that would have necessarily produced an error here, and therefore it went all the way through. So the bottom line, and look, could you have necessarily figured that out to do that test? Maybe, maybe not. You do have to try to do tests that you try to test all the different input that you can that's reasonable to get things to make sure your program's working. Had those people tested some floating point values, they would have found out that this absolute value function didn't work, regardless of whether there was a compiler warning or error. OK, so they would have figured that out. So in the future, make sure you're doing lots of tests on your own code for different what we call corner cases and cases that are the types of input you expect. You won't always catch exactly the stuff that we try to throw in there, but you should try to do as much as you can. And maybe later we'll talk about writing test functions to do that. OK? All right, so testing would have discovered this. So you got to test your code. You can't just do it, test it on one input, and be done with it. Okay? Any other questions on that? All right, anything else on homework 1? Awesome. Okay. All right, so labs start this week. And we already mentioned that. When you go to lab, the first lab that we're going to be doing is this lab called Hookbook. It was actually, I believe, written by Ben Hescott, who taught this course before. I switched it up a little bit to meet some of the things, or to be a little similar to what we're doing in class here. But it's very similar. And what we're going to do is we're going to create a pirate social networking app. Okay, the pirates have gotten on board with social networking, and they're going to be starting their own pirate social network called Hookbook. And what we're going to be doing is we're actually going to be putting dynamic arrays inside a dynamic array. Okay, so we have built, and you'll see this when you get to lab, we have built a dynamic array, and it's going to have a dynamic array inside of it that you guys get to build. Okay, so you can use that to figure out if you forgot exactly how to do that. And then the person leading the lab should go through some of this as well. Okay, you're going to have to write one method and then this destructor as well. Hopefully the lab leader will be able to describe what the destructor is and how it actually fits into the code. But the bottom line is, if you create a list, you have to destroy it when you destroy that list. And that's what the destructor will do. OK, and you also need to expand the array like we talked about the other day in class, expanding an array when it gets too big. Okay? And then finally, we'll use this thing called a struct. If you took Comp 11, you should have seen structs already. But here's what a struct looks like for our Hookbook. Okay? It's going to say struct. And what this is a structure. Structures and classes are actually very, very similar. In fact, underneath the covers, they really are the same thing except for a couple small tweaks. Okay? But here's what it is. You have this structure called pirate, and it's got a bunch of these elements in it. And you're going to pass these pirates from one method to the other, back and forth. Okay? And the pirate structure is going to have this member ID, and it's going to have a name, and you're going to have a friend list. And this, by the way, this is your dynamic array that you're going to create. And then it's going to have how many friends you have and how many you're capable of having. And that is based on whatever your initial capacity is. Okay? So that's what you're going to do. And you're going to be able to pass these around. Structs and classes are very similar. Here's the difference. The big difference is that everything in here in a struct is actually automatically declared public, versus in a class, things are automatically declared private. That's really the big difference. But we'll use this. Sometimes it ends up looking like a little less code because there's not much boilerplate and all that. So anyway, that's what we're going to do for lab 1. Okay? And you can ask lots of questions about that when you get into the lab. The bottom line on the labs, much like Comp 11, I believe, when you go to lab, you'll have like an hour and 15 minutes, I guess. And you'll get a little kind of refresher on the material, and then you'll go and design this code and be done with it by the end. So there's no like take-home work from the lab. Okay? No take-home work. All right, any questions on the lab? Last minute stuff on the lab? OK. All right. So let me go back. We're going to go back to what we did last week. And we're going to go back to our insert method in our array. OK, bring yourself back to last week and do this. Now, I actually wrote this and then submitted it, and then we didn't even talk about it in class. I mentioned it briefly, and then I said, don't worry about it. Well, it's a good thing I didn't, because I actually screwed up on this class. Okay? One of the things you'll have to start learning how to do, especially for the midterm and the final, is reading through code and figuring out where there are bugs in that code. Okay, that's like I might ask a question or two like that on the midterm. Hopefully it will not be hard stuff, but it might be like, look through this code and tell me what's wrong with it. Okay, there are actually 2 things wrong with this. I messed up twice. I am certainly not infallible. I messed up twice, and you can hopefully figure out where this is. Now let's go back to what this actually is doing. What this is supposed to be doing is it's inserting, actually I think I have, actually before, yeah, this is it. We're inserting at some index, and we're inserting a value. Okay? So and then what we're doing is we're reserving the capacity if we need to, and then we are going through the list and just looking to see if I might have accidentally changed this back. No, I didn't. Okay, so let's see. Yes, I didn't change this back. So there are actually two different problems with this. Can anybody point out one problem with this list? Or with this method, what I might have done wrong? Let's go through it if you can. Anybody think about what I did wrong on this one? Yes? I think the loop might never end. Yeah, take a look at this loop. I screwed up here, right? For size t, number, in other words, an integer, we're going from our used value. We're basically moving everything to the right one position. And what I'm saying is go from used plus 1 while I is greater than the index and increase I, right? So why would it never end? Yeah. So while it's greater than, so it should actually, yeah, it may actually start greater than index, or it might not even run at all. Yeah, so that was definitely a mistake. Okay? All right. And then there's one other place in here where I didn't do something, which is down at the bottom. Anybody pick out what else I might not have done here? I forgot to do. What are we doing to this? What are we trying to do here? We're trying to add a value, right? So we've got our used in here. And what did I forget to do? Yes? Nope, we didn't forget to delete the array. The reserve actually deletes the array for us. Good idea, but the reserve deletes the array for us, right? What don't I actually do? Yeah?
You didn't increment used.
Yeah, I actually inserted something and then didn't tell the program that I've got one extra value. It kind of looks like it up here. Maybe that's where I got confused. Like it looks like maybe I'm adding up here. But no, I didn't actually increase used by 1. Okay? So there's two mistakes in there. I didn't purposely make them, even though I should have claimed that I purposely made them, so you'd be able to do this. But I did not purposely make those. I just made a mistake here. Okay? And that's it. Now, let's fix this. OK, first of all, let's fix this. So let's see. Here is, OK, I changed this a little bit. Here's our fixed one. I didn't actually insert it at the index value. Let's see. You know what? I might have gone back and fixed that. The first part anyway. Well, anyway, in here, I fixed it. So now we're actually going down here. OK? We're going down to the values. We're replacing the one at the end, and then replacing the one next to it, and replacing the next to it, and replacing the one next to it, all the way down to the in this case, the first value. And then we're inserting our value in there. OK, and I have increased this. OK, let's make it a little bit bigger. This is now what I was originally thinking we were going to do, which is start at some index and insert the value at that position, and then move everything up, and then insert it. OK, so here's what it is. What is the bottleneck in this array insert function? What's the thing that might make this not so efficient? Yeah.
Inserting or moving every single value.
Yeah, moving all these values, right? If you've got values and you've got this array and you're trying to move, and you start out with one like 3, 7, 1, and you want to insert here, and you move 3 to here, that takes some time, and 7 to here, that takes some time, and 1 to here, that takes some time, and then you put the value there. That's where the bottleneck is. Okay, that's where our little bottleneck is. So it's right in this little case. Okay, and this is one of the problems with arrays. All right, inserting into arrays takes time. Why? Because you have to move all this stuff around. Okay, there is a better way. Okay, there is, well, I should say there's a different way. Not necessarily better, but there's a way we're going to talk about to do a different data structure that you guys probably saw in Comp 11 as well. And we're going to review it today and hopefully get everybody up to speed on it. Okay? What we're going to create, okay, if we're going to be doing a lot of inserting, deleting, there's a better data structure for this called a linked list. Okay? We're going to build up this linked list, and then I'm going to get some people up here, and we're going to actually go through. It's going to be like community theater a little bit. Okay? We're going to go through and we're going to actually demonstrate linked lists and how they work, if this works all right. Okay? So we're going to build up this little node class. Now a node, well, first of all, let me just give you the bottom line on what a linked list is. Okay? A linked list is not like an array in that all the values have to be right next to each other. We're going to have these things called nodes. Okay? We're going to have a node. And a node is going to be a little chunk of data that actually has the ability to say what the next node is. And that next node is not necessarily right next to it. In fact, it could be anywhere else in memory, more or less. And it's going to have two different pieces. Okay? It's going to have a data piece, Okay? And it's going to have a pointer, which is what we had mentioned a little bit earlier. Okay? A pointer, which is also pointing to a node. So it's kind of an interesting idea that's like self-referential in the sense that a node knows about a node. Okay? This node is going to have the ability to hold some data that we care about, and then it's going to be able to say, OK, I'm going to point you to some other node which has different data and also has another little node pointer to the next one. And we're going to build up these what we call links, okay, into this linked list, and that's going to be our data structure. In memory, it could look like this, where you have one node here, and then another node here, and another node here, and this one could point to this one, and this one could point back to this one, and this one can point off somewhere else. It doesn't matter where the actual memory is for these linked lists. Okay? So that's what we're going to talk about. All right. Let us start out with this node class. Now, before you may have seen, if you did this in Comp 11, you may have seen the node as a struct. Right now, we're going to talk about it as a node class. Okay? It's, again, classes and structs, very, very similar. But we're going to set this up as a class just to keep this object-oriented thing going. OK. Boilerplate stuff, right? We've got our type def, which we talked about before. That's going to be, in our case, we're going to store integers. The type is going to be called value type. We're going to have one constructor, which is nice. And then we're going to have a couple setters to set the data, and then getters to actually get the data. Again, boilerplate stuff. And then finally, we're going to have, this is the meat of it right here. In fact, I think I have this on the next one here. Oh, no, that's just the constructor. Here it is. This is our data, right? It's just a value type. It's just, in this case, an integer. And our link, which is a link to another node. Okay, and that's our data. Or that's our, well, those are our two pieces of data in this class. Okay? Any questions so far on this? Straightforward stuff? Yes?
What's the other first pointer?
What is which first pointer? Get link. Good question. Get link is going to return the value of this link. So it's going to say, where in memory is that? And this is for the object-oriented part that we're not going to let other classes that call node get directly to this link. We're going to have to call this getter to get the link for us. It's just an object-oriented idea in that case. OK. All right. Here is what our constructor is going to do. OK? Our constructor is going to do, it's going to be very simple. Our constructor is going to say data is going to be 0, just to kind of initialize the data. And then we're going to set the link to this value called null. Now, null is actually the value 0 in most programming languages. It's actually a value of 0. And you can't have any memory address at 0. You're not allowed. I mean, there is a memory address there, but you're not allowed to actually reference it without getting an error in your program. Okay? And that's all the constructor is going to do. It's going to say, OK, data equals 0. And link equals null. And that's going to set up our constructor. Okay? It's going to set up our little node, which is one of these guys. Right? It's going to set up our little node. OK. All right. I threw this in here because before we do anything else, we've got to be able to print this list. Okay? And I'll go through what this is kind of quickly, and then you'll see. Here's what the print list does. All this stuff, it seems like a lot of stuff. I'm going to basically print a little bracket. And then I'm going to do these things called iterators. Now, this isn't technically the same type of iterator we may see later in the class. But I'm going to use this term because you've got to get used to what an iterator is. Did you see iterators? Or did you ever talk about an iterator in Comp 11? You did. OK, so you guys know what that means, right? Iterator means I go from one value to the next, to the next, to the next, to the next. And I step through some values. If it was an array, I would go from 1 to 2. In our linked list, we're going to actually step from one node to the next node, to the next node, to the next node. In this method, we're going to actually print out the data each time. OK, the data in each link. OK, so here's what it's going to do. OK, it's going to say, while iterator equals null, by the way, if you're in a linked list, the last node in your list needs to point to null. Okay, that's how we know that we've made it to the end of the list. Okay, you got to get all the way to null. And once you do that, if your If you actually are a null pointer, you are not a node anymore, and therefore you're done with counting through your nodes. Okay? So while iterator is not equal to null, what we're going to do is we're going to get the link of that iterator. Okay? And I guess I should start out what we did here. We're going to start out, we're going to pass this print list, this thing called the head of the list. Okay? Well, the first node in your list has a pointer to it. This is not another node, by the way. It's just a pointer that points you to that first link. Okay? And that means that this is actually the head of the list, okay? The first element in it. Okay? You know it's the head of the list because the head pointer here, this is head, okay, actually points to it. Okay? And so that's how we're going to do that. So what this print list is going to do, it's going to get this head in here, and it's going to go and it's going to say, set this thing called an iterator to the head, and then walk through this. Get the link of the first item, and then print out the data. Get the data and print it out. Okay? Get the data here. And then actually set the iterator to the link that this one's pointing to. So now the iterator is going to point here, and it's going to return here, and then it's going to first check and see if it's null, which it's not, and then get the link, and then get the data, print the data out, and then rinse and repeat. Okay, question?
So it says while iterator does not equal null, and that's just for where the iterator is pointing to current.
Yes. So the iterator, right. So first of all, the iterator is set to point to wherever the head is pointing to. That's what the first statement says, which means it's going to be pointing here. It's a pointer as well. It's going to be pointing here, and then it's going to go here, and then it's going to go here and be set equal to null, and that's where we're saying, well, we're done. Here, we're all done.
It says if iterator at get length, and that's just so it's the one that's after the one it's pointing to, is essentially what that says.
Yes. This one is saying, you're right, this one's saying, and the reason I did this is to be a little fancy about it. All I'm saying is I want this to print the number or the data and then a comma. And when I get to the last one, instead of printing a comma again, just print a bracket at the end and then return. So that's what really this one is. This is saying the link of whatever the iterator is, what's that pointing to? And if that one happens to be pointing to null, that means it's the last one. That's how that works. Okay? All right. Okay. So I got this down? All right. Okay. All right. Now, here's the part that I haven't tried before. I need a few volunteers. Now, here's what you're going to do. You're going to come up on stage, which means that you're going to actually be on the video, which means that I have to get you to sign a waiver. Right? Well, technically, I guess I do. So at the end, if you don't want to be on a video, don't volunteer. But here's what I'm going to need. I'm going to need altogether about 8 people to volunteer. Okay? And when you're going to come up here and you're going to hold these little things up, and we're going to actually go through this. Okay? This is no pressure here. We're not going to do that. Do I have any volunteers? Come on up. Come on up. 2. Come on down. Up. Come on up. How about a couple of females? Anybody? Yep. Come on up, Elaine. All right. Come on up. Okay. So that should be good for right now. If we need more people, we'll do this. Here is what we're going to do. Okay? We're going to run this little program here. Okay? And I'm going to demonstrate this. And here's what we need. Okay? First of all, we need somebody to be null. I'll make you null over here. Okay. You're going to be null. Now, unfortunately, you don't get anything to do except stand there and be null. Okay? So that's what you're going to do. Okay. We are also going to have a node pointer called a node. Okay? I'm going to actually put you as a node there. Okay? A node is a pointer to a node. Okay? You're going to be, and in fact, one side of this actually points to the node. Okay? And the other side says, well, I'm question mark because I have no idea where I'm pointing. Okay, we can actually have pointers that don't have any idea where they're pointing. Okay, so you're gonna do that. So in one hand, you can hold the a node so everybody knows who you are, and then you can do that. All right. Next, we're going to have a temp node. Okay, or sorry, I lied. We're not gonna have a temp node. We're gonna have a temp node pointer. Okay, so you also get a pointer. Okay, and then we're going to have a head pointer, which is the same thing, and you're gonna have a head pointer there. Okay, and then we're going to have some other things that we'll get to. So you guys will get to participate in a few minutes. OK, so we're going to start out with this. Now, let me bring up a different screen here. Hopefully this will work. A little later, if we get to it, I'm not sure we'll get to it, but a little later I will show you the coolest thing. It's called a debugger, and it actually builds some of this for you. So it's not actually people standing up here. OK, what I'm going to do here, I'm going to show you mine on my computer first. And what this does is it allows me to step through the program piece by piece. And it puts this little green bar up there. Can everybody see that? You guys can't see it, but you'll have to turn around and see that. OK, so what this is doing is it's going to start, and it's going to put a little green bar so we all know where we are. Okay, in this program. In fact, it actually is running the program on my computer, which is kind of cool. But we're good. OK, but let's first of all start out here. So let's pretend we're here. OK, have we created anything yet? No. So actually, these guys don't even exist. So right. So pay no attention to the people behind the curtain. Right. You guys can even put those down. You don't even exist yet. OK, you don't even exist yet. All right. Null exists. OK, you're the only one who exists. You actually exist. OK, null actually exists. All right. The first thing we're going to do, OK, is I'm going to come down here, and we're going to create this a node pointer. OK, so you have been created. OK, and go ahead and point your value where you think you are pointing to. OK, so if you think you're pointing to null, let's do it this way. Just put it way up high and kind of point it that way. All right. Whoops. OK, so that's that, and we're going to go there. OK, and then we create the temp pointer. OK, and temp pointer. And are you pointing anywhere? All right, so you're pointing down that way too. OK, and then we're going to create the head pointer. OK, and then you're pointing. OK, now, question. Are these guys right about where they're pointing? I see a lot of no's. Don't worry, guys. You might not have known that. At this point, all the computer has done is said, we're creating these node pointers. It does not initialize them. It does not point them to null. It says whatever's in memory, you're pointing there. Whatever is at that memory location that says where you're pointing there. So you guys are actually, you should flip them all over. You have no idea where you're pointing. OK? Right now, they have no idea where they're pointing. OK? Null's still good, but he's not getting pointed at right now. OK. All right, now we're going to go on to this. OK. So a node, OK, is now calling the constructor. What did we say the constructor did? It creates a node, and what two things does it do to that node? It initializes it to the data to 0, and then it points it to null. OK? So before we do anything, we actually have to create a node. OK. So that statement creates a node. That's going to be you. OK. You're now a node. And it sets its value to 0. You have to hold this right next to it. There you go. Value to 0. OK. And it actually points its value to its node to null. So you actually are pointed to null. OK. All right. OK. Where is a node now pointing to? It's pointing to node. So you never actually point to null at all. You're actually pointing to a node. OK, so you kind of aim it that way. This is going to be a little hard to see sometimes with everybody standing up here. OK, so a node is now pointing to the node. OK, the one we just created, which is now 0 and pointing to null. OK, the other two aren't doing anything. Well, now they are. OK, because what we're going to do is we're going to set temp to also point to what a node is pointing to. OK, so temp is, there we go, is now pointing towards the new node. And we are also going to point the head at the new node. Actually, I can do it if I do this. Let me see if this works. There we go. I can actually get this to do this. There we go. Now we're there. OK, and now head is now pointing to the new node. OK, so everybody see what's going on? We've got 3 different pointers. They're all pointing to this new node. Here's why we're going to do that. OK, because we're trying to build up this new thing called a linked list. OK, we have 1 node so far, and everybody gets to point to that. By the way, head, you should probably get used to you should get comfortable for right now. OK, I'm just giving you a heads up. You might want to be comfortable. OK, so let's see what we do next. OK, all right. We are going to tell a node to say to what it's pointing to. Change your value to 4. OK, so I should have a 4 in here somewhere. If I don't, it's going to be some other value. Hang on. Where is it? Where is it? Ah, I probably left it in my office. Hang on. No, 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 no. I don't even have a pen to write this. Yes, I do. Do you have a pen? Write big 4 on there. All right. So a node is, we're going to tell the program, tell a node what it's pointing to is now going to be 4. Okay, thank you. So you basically say, whoop, what are you pointing to? You're pointing to him. Oops, thank you. And that is now, you are now 4. So far, so good? OK. Now we've got to do this print list thing. OK. Elaine, you want to be print list? Right here. OK. Print list is going to do, what did we say print list is going to do? Print list starts at the head and says, who are you pointing at?
Who are you pointing at? Node.
OK, he's pointing to that node. And then the print list goes to that node and says, what's the value?
4.
The value's 4. There you go. OK, and then prints out 4. Right? OK, but we're not done yet. OK? What did you do next? You said, where are you pointing?
Where are you pointing?
Nowhere.
No, you're not pointing nowhere. That would be bad, right? You're pointing to null. OK? So if he's pointing to null, what do you print out now? Nothing. You're done. That's what gets printed out. In fact, gets brackets around and printed out. OK, that was part 1. OK, everybody get what happened there with the setting of all these nodes? All right. So that's what happened there. Now, once we do that, then we're going to do this. We're going to create a new node. In fact, Elaine, you're now going to become a new node. OK? I'll take the print list from you. I'll be print list. Anybody else want to be print list? You want to be print list? No? I'll do it. I'll do it. All right. So we're going to create a new node, and we're going to set a node to point to it. In fact, walk down there and point to the new node that you're created. OK. Is the value that's getting pointed to now by a node, does it have a value yet? We're doing this. We're in the middle of this. We have just done this constructor, let's say. Does that have a value?
0.
Well, it is. It's going to be 0 because in that constructor, we're going to do that. So you are now 0. And we are pointing that to null. OK, so everybody gets what's going on now. The head is pointing to this first node. Temp is actually pointing to the first node too. OK, a node is now pointing to the node that we just created. And in fact, it's going to next, we're going to set the data to 2. Aha, I do have a 2. OK, it's going to set the data to 2. And we're going to go, where are you pointing? You're pointing to Elaine. Elaine gets the value 2, like that. OK, that's what our set data does. Now watch what happens. Now we've got 2 nodes, OK, but they're not in the right, they're not really doing much with each other. OK, they both, right? Node 4, which one are you pointing to?
Null.
You're pointing to null. And a node, where are you pointing? No. OK, we need to build this list up a little bit more. OK, we need to build the list up by setting temp, OK, saying temp, set what you're pointing to point to that new node. OK, so you actually don't do anything yet. Temp actually doesn't change anything of its behavior yet. But what it says is, where are you pointing? You're pointing to a node. Now you are going to point to the new node we just created. OK, so I know it's a little tough to see because it all looks like we're pointing at null, but we're not. We're now pointing there. OK, so now we've got 2 nodes, and they're both pointing to a node. OK, we've got a node now being pointed to by the first one that we created. OK, and then now temp, you've pretty much done what you needed to do, right? Oops, you have done what you needed to do. So we are going to now set you to point yourself also to a node. The reason we're doing this is so that next time around, we're going to run through the same process again, and we'll be all set up to do this. OK, so now you are actually pointed to a node as well. OK, and then print list comes along. OK, print list. I go to the head. I say, where are you pointing?
First node.
The first node. What's your value?
4.
4. OK, I'm going to write down 4. Boop. OK, all right. Where are you pointing? You're pointing to a node. OK. No, you're not pointing to a node. You're pointing to, sorry, you're not pointing to him. You're pointing to what? The same node that he points to. Right? That's an important one here. He's not pointing to the same thing. He's pointing to they're all pointing to Elaine over here. OK? What's your value? 2. OK? Where are you pointing?
No.
I'm done. Boom. OK? All right. And that should do that when I print the list. There we go. And in fact, you can see up here, it's actually doing exactly that. It's printing 4 and then 2. OK? All right. One more time. Okay, we are going to need one more volunteer maybe. Come on down. All right, we are going to create a new node. Okay, we're going to create a new node. That's going to be you. Okay, we're going to actually use the constructor to create your node. And you might want to go down there because eventually you're going to be down there. In fact, slide down a little bit. OK, we're going to create the new node. We're going to initialize the node. And you are going to point where? You're going to point to null. OK, now, Elaine, make sure you're also pointing to null. OK, there you go. Pointing to null. OK, two people pointing to null. OK, all right. And now we're going to go ahead and set the data to 12, which means, right, I go to where I say, let's see, a node set data to 12. So who are you pointing to? You are pointing. Nope, you're now actually pointing to the new one. Oh, no. Yeah, because, see what I guess I didn't say it right. We're creating a new node and setting a node to point to it. So you're now actually pointing to the new node. OK, and then we are setting that value where you're pointing to 12. OK, like that. All right. OK, now we're doing the same thing that we did, the same drill we did before. Temp. Who are you pointing to right now?
A node.
You are pointing to which node? You are pointing to Elaine's this node right here. This is why this isn't working so well in terms of pointing. You're pointing here. OK? You're pointing there. And what you're going to do is you're going to say set that link to point to the new node that we just created. OK? So Elaine, now you are now, instead of pointing to null, where are you pointing? You're pointing to the new node. OK? We've done that. I'm going to redraw this on the board in a second. OK? And then you are now, we're going to go ahead and set the temp to be to the newest node that we just created. So now you're going to point over there to that new node. OK? And then we're going to print the list. All right, to print the list, I go to the head. I say, where are you pointing? The first node. You got to get, yeah, you're like, OK, what's your value? 4. OK, 4. Where are you pointing? You're pointing to Elaine. Elaine, what's your value? 2. What are you pointing to? There you go. You're pointing to the new node right over there. What's your value?
My value is 12.
12. What are you pointing to? No, you're done. There we go. Or I'm done printing. OK? Now, let's see what we've got here. We have 3 nodes that we've just created. The first node is pointing to the second node, which is pointing to the third node. OK? First node is pointing to the second node, pointing to the third node. And the third node is pointing to null. OK? We still have this value of a node, which is what we use to set all this up. And that's pointing to the last one. We're also pointing our temporary node to the last one. The head just kind of sat there and pointed all the time to the same node. And we're good to go. OK? Does everybody see how that worked in there? There's a couple tricky things you need to figure out. A, when you create a pointer, it doesn't point to anything. OK? It doesn't point to null. It doesn't point to anything. Some languages it does, but in C++, it doesn't. OK? The head always points to that first node. And the last node always going to point to null. And then we have to do some special things to make all the nodes point to the right place when we create a new node. OK. Questions on that? Yes?
Could you repeat what the temp point to sending the node?
What temp set link does?
Yeah.
This one right, this one right here?
Yeah.
OK. So go back a step. Before, you pointed towards the last node. OK? He was pointing right here. OK? What we're saying is, because we just created this new node, we want this node, instead of pointing to null, to point to the new node we just created so that it creates this nice link. So what it's doing is saying the temp goes over to this node and says, wherever you're pointing, now you're going to point to the last node we just created. That's what's happening there. Set link is going to say, where are you linking to? OK? So we're setting the link to that new node that we just created. The link of what temp is pointing to is now pointing to the newest node we created. OK? I'll probably have to draw it out a little. I'll draw it out and make it a little more clear in a second. OK? And then we're done with this program. OK? I thought I might have you guys do like inserts and things, but it's going to be too crazy up here. So thank you very much. Stick around after if you could, just to do this little signing of the business of the thing. But thank you, everybody. Give them a round of applause for doing this. Thank you very much, and I'll grab these. OK. Thank you. Oh, thanks. No worries. Thanks. Yep. Thank you. All right. Good job, Noel. All right. So, does anybody want me to repeat how that worked again, just so you can see it one more time? Yeah, I'll repeat this just so we can get the idea of what happens. I won't go through all the little details of the hang on. Whoops. Wrong one. There we go. There we go. OK. Yes. This code is online. Yes, it's on the website under the lecture for today. OK. All right. So first thing we do in this little part of the program, OK, we create 3 nodes. Sorry, I lied. We create 3 node pointers. OK, a node pointer, a node pointer, and a node pointer. And this one we're going to call a node. Actually, I think I made it camel case. A node. This one we called temp. And this one we called head. OK. All right. So here's how we start creating a linked list. OK. First thing we do, we create a node. OK. And I'll put null over here too. OK. First thing we do, we create a node. OK. It's got data and it's got a link. OK. We'll call D and L for data and a link. OK. We created that node and we had a node point to it. OK. And in fact, when we created it, the constructor said, let's initialize it. Data 0, link goes to null. OK. So far, so good? Everybody gets that part. OK. Then we said, well, we got to do a little more setup here. So let's make temp and head also point where a node is pointing. So temp is going to point here. And a node is going to, or sorry, head is going to also point right there. Everybody gets to point to the same location. In fact, if we called set link for any one of those, it would set the link for that, or set data. It would set that for that particular node. One node, 3 pointers to it right now. OK. So then what we said was and we are now up here, we said set the data equal to 4 for whatever a node is pointing at. A node points here, set that data equal to 4, like that. Okay. All right, and that's the first link. Okay, and well, do we have a real linked list here? We do. We've got a head pointing to some link, and then that link points to null, meaning that if we go print list head, we say, hey, head, what are you pointing at? Oh, I'm pointing at this link here, or this node here. What's your value? It's 4. I write down 4. And then I say, what are you pointing at? Null. Oh, I'm done. So far, so good? All right. Then we go to now we create a new node. OK. So this other one, this line right here says create a new node and set a node equal to it. Data link set a node equal to it. I need my eraser here. OK. This is going to get a little crazy, but probably not as crazy as all that stuff when we run around. A node is now going to point to this guy. OK. This is going to look like a jumble of points here in a minute, but the computer actually does it better when it sets it up. OK. And this is now pointing there, and it's set to 0. I don't know why I did that. 0, and it's pointing to null. So now we've got two nodes, but they're both pointing to null. So we need to do a little more like manipulating here. Okay? After we set the data to 2, then we say, hey, temp, to whatever you're pointing at, set its link to the new node we just created. Temp points here, so it sets this link, changes it from null to point to the new guy. Okay? And then we say, all right, well, we're done with temp changing stuff. So now we're going to point temp to point to the new one. Okay, why are we doing that? So that we can do this again when we do the next little change that we make. Okay? Okay. Head still pointing to the first one. A node, which is the one we just created, is over here. Okay, actually, I forgot to set its data. Sorry. Data got set to 2 up there, like that. And then now we've got 2 links. Do we have an actual linked list now that is legitimate? We've got a head that points to the first one. It points to another node. That node points to null. We're good to go. When we print it, we say, hey, head, what are you pointing at? I'm pointing at this one. What's your value? 4. OK, where are you pointing? I'm pointing at this one. What's your value? 2. Great. I write down 2. Where are you pointing? Null. I'm done. OK, good? Question?
So I'm just wondering, in the beginning of setting all this up,
Yep.
there are a lot of pointers, like 3 whole pointers. Like,
Yep.
So is 'cause in the past, I know in 11 we did a little bit of like temp and head, not necessarily having like a 3rd pointer. I'm wondering what the utility of that is.
Good question. The 3rd one is just it's just the new one that we're creating. You need to do that one in this case so that you know where the previous one was to set its link. So if you did it with 2, I'm surprised if you did it with 2, but I guess there's probably a way to do it. But then you have to maybe keep a link to the link, or a temporary value to that link, so that you can change it, or to that node so you can link it eventually. But you do have to do that. Yeah.
So I guess maybe I'm just forgetting something about the heap, but whenever you're making a new node,
Yep.
since a node is just an address, right? So you're setting an address to a node. Is that
OK, good question. So the question is kind of like, hey, there's this memory out there, and we've got this pointer, but it doesn't really point anywhere right now. What we're doing when we do this, when we do new node, that actually calls our constructor, which says to the memory system, give me some memory for a node, and then I will give you where that node is located so that you can properly point a node to it. And it actually points a node to that location. So there's the memory that gets created when you do the constructor, which is actually where that's actually going to be located. That node is going to be located. OK, good. All right, and then we keep going down and doing the other thing. We do it one more time, right? We say, let's create. I don't have it up here, but we'll start from here because it's really no more battery. We're going to start at the one that says a node equals new node again. OK, you're going to create another node. Another node. Going to have data and link. OK, a node is going to point to it. OK, actually, it doesn't quite happen in this order. I'll go this way. Right, a node's going to point to it, right, and it's going to initialize it to 0 and have the link point to null. Then we have to go through this whole process again, where we say to the temp node, hey, wherever you're pointing, point that to our new node. Point that to our new node. OK, and now you can set what you happen to be pointing to also to that new node, so that we can do this again if we want to in the future. Now this is going to also go down there. And we are going to be good to go. OK, 3 link. Do we have a link? Do we have a proper linked list? We do. We've got a head points to the first link, which points to the second link, which points to the second node, which points to the third node. The last node points to null, and we're good to go. OK? Does that make more sense about how this stuff actually works now? OK. All right, so let's go on to a couple other pieces of this. OK? If we want to count the links here, in other words, how long is our list? This is how we might do it, right? We would say just realized I have another battery. We would say that, OK, we would pass the list our head, right? And we would say, let's make a temp. We don't actually have to make a temp, as it turns out. I did just to kind of keep the semantics the same. Oops, still not working. But what's going to happen is we're going to point to the node. We're going to have this new temporary node. And we're going to start counting links. And that's all we're going to do. We're going to write a little loop that says, until we get, while our temporary node is not equal to null, increase our count. OK, so what's it going to do? It's going to start out, and it's going to say, OK, we started by saying temporary is pointing at wherever the head's pointing. OK, temporary is now pointing at wherever the head's pointing. OK, count it. 1, Okay? Change temp to whatever it's linking to is linking to, or what it's pointing to is linking to. So now we're going to say temp, where are you pointing to? You're pointing to here. Now this is going to be over here. Okay? And count it. That's 2. Do the same thing again. Where's this one pointing? This one's pointing to here. We set this to our link over there. Count it. 3. Where are you pointing to? You're pointing to null. Are you null? Yes, we're done counting. And then return that value. Okay, so now we've just counted the list. Okay, we've counted the linked list by walking through it. Walking through a list is not fast. It's one thing we have to get used to. If you're going to count a list, okay, you actually have to count every value in that list, or you have to touch every single link in that list. Okay, that's bad for a number of reasons. When we had our array, how did we get the length of our array? Anybody remember? Yeah. The index. Well, it was the index of the used variable, right? We actually kept a variable around that said used equals the length of our list. And all you need to do is grab that value and you're done. You can't do that in a linked list. Now, you could have a linked list function or a method that keeps some of this extra data around. And that's how they speed some of these things up. You could. Our node doesn't keep a value of how many total nodes there are. Okay, you could do that, but it doesn't in this case. Okay, so that's kind of slow. It's also slow because when you touch lots of different pieces of memory, the computer can't utilize its cache very well. In other words, when you utilize a certain chunk of memory over and over again, and it's one chunk, the cache can say, I'm going to take that whole chunk and put it in this really fast part of the memory, as we call it, the cache. You can't do that with a linked list if memory locations are all over the place. So not that fast in that way. Where does it beat the array? It beats the array in how much did we have to do to actually increase the length of this list, right? We didn't have to do anything. We didn't have to actually increase the length. This is not the best example for that. We'll get to that next. Okay? All right. So we started at the beginning here and we said we had an insert method for our array. Okay? Here's what we're going to do to insert at the head of the list. What we don't have to do is move, 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 move. We don't need to do any more moving to do this insert. Okay? Let's take a look at what we have to do insert. Okay? We create a new node. Okay? Temp here is not pointing anything yet. Well, it was, but now it's not. Okay? We are going to, and if we want to insert a new node right here at the head, what we do is we create a node like this. Okay? We've got our new node, data and link, and we initialize it. We actually, in this case, initialize it to the value. We actually are going to call this insert at head. We're going to pass it the head and the value we want to insert. So let's say we want to insert 7, right? We put that in there, and then it's going to, well, actually, it's going to create it and make it 0. First, it's going to create it, make it 0, and point this guy to null. I'm going to move a null down here. Well, I probably shouldn't do that. I will make it point to null in the roundabout way. All right, it's going to get a little crazy. OK, but anyway, we're going to create that. It's going to point to null. Then we're going to say, set the link to point to the head, because we're inserting this new node at the head. OK, so all that work going to null here, not needed, because what we're going to do is we're going to say, you get to point to the head. Now, head, if you'd stayed up here earlier, you would have gotten to do something here, right? Because you would have actually changed. Okay, and I'll talk about what that means in a second. How do we actually change this value? Okay, we're going to create that new node, set its link to the first link. Okay, that is where it says temp set link to the head. Okay, that's now pointing to the head. We're going to set the data to the value, which we said was 7. Okay, we're going to do that. And then we are going to now say that the head is now going to be the new value that the new node that we just created. So head actually does get to change to this new value. Now, do you see what we've just done? We've taken a new node, we've created it, and we've inserted it right at the beginning there, and we didn't have to move anything else. In fact, these two never got even looked at This one didn't even get touched. It's just we were pointing to it. So nothing happened there. That's where we actually get a time savings when we do that. Okay? And then we're returning the head. Now, how do you actually do this? This is kind of a C++ thing. Oh, I'm going to try to use it. It's not going to work. This is actually a C++ thing as well. When you want to change a value of a variable inside a function, you'd better pass it a way to get directly to that variable. Okay? What does that mean? You see this right here, that little ampersand? I mentioned it the other day. That says when you pass in this head pointer, give me a reference to that pointer that I can actually change that value itself. Normally what C++ does, if you didn't have that actual ampersand there, it would give you a value that was pointing to the right place, but you couldn't change what that value is. What we need to do is we need to change where head is pointing, right? And to do that, you actually have to pass in the actual reference to that variable. Okay, it's a little subtle, but you need to do that so that you can actually make the changes to the actual pointer that you passed in to begin with. Okay, it's a little odd. Yes?
Can you use the A node to insert a new node as well? Or you can.
Yeah, well, so the question was, can you use the A node? We're kind of going beyond that a little bit, where now we're just saying, don't worry about this A node that we created earlier. All we need is the head of the list, and we're going to use that head to create it there. That's all. You could use whatever. If you have a pointer to a node, you can use that to insert at that point. And we'll get to that in a minute when we show you how to insert somewhere else in the list. Okay? Any other questions on inserting at the head of the list? Yeah?
So just what's the second thing in the parameters? Because it looks like
Oh, yeah, good question. The first thing in the parameter was the head pointer. The second thing was the actual value that we're trying to or that we're actually trying to set. In this case, it was 7. Okay? The reason I had it say node value type was because that was the type of value that I'm putting there. So in fact, it's an integer in this case. But I had set that in the node class. So that's where you need to do that. By the way, this function is not a member of the node class. And that's an important point. This method is not a member of the node class. It's its own class. It needs to know about nodes so that it can import the right value. But it is not part of the node class itself. Okay? We could create another linked list class, which maybe we'll do at some point. But we could do that, and that maybe we could include these values in there. But at the moment, all you know is this is a method that knows about nodes, but it's not part of the node class. Because you don't need to drag along the inserted head method into every node that you create. Okay? All right. Questions on inserted head? All right. Let's look at insert anywhere. In other words, insert at some other location. Okay? Let's see what we would do if we're trying to insert somewhere else. Okay? Let's say we want to insert right here. So we're going to insert a node right here. Which node do I need to pass to my function such that I can insert something here? Can I pass it this node? If I tried to pass it this node, what does this node know about? It knows about its own data and then the one thing after it. Does this kind of a linked list know about anything before it? No. In fact, that's one of the downsides to this list. It's called a singly linked list. Is that how you spell singly? I don't even know. Is there an EY in there? I don't know. Anyway, it's only got one link. In other words, it's a link going one direction. So if you're going to traverse this list, if you're going to go down the list, you can only go in one way. You can only go one direction. If I happen to have a pointer here, I could never get back to here unless I went back. I could never go back one to here unless I somehow got the head again. You can only go one direction in this type of linked list. Later we'll talk about a doubly linked list, which is actually where you have links going both directions. So at least you can go backwards and forwards. But in this case, if we want to insert a node right here, we need to somehow get the previous node. Okay? How you actually go about getting that node depends on why you want to insert something here. Okay? If you happen to say, well, and in this case, if it's not a these lists don't happen to be sorted. So really inserting in the middle is a little strange in some sense. But if you have some way of, if you have some list that you want to keep in some order, well, if you want to put something right here, you need to know the one before it. Okay? How would you get to that one before it? Different ways. We'll look at a search function in a little bit to search through. But bottom line is you need to give it this pointer or this node in order to insert here, which I'll show you how to do. So if you look at this, okay, again, we are inserting after, basically. I should probably put insert after is what this could be called. Some previous node to where we want to put this, and we're giving it this value. Okay, same sort of idea as before. Okay, you need to first create a temporary node or temporary pointer and a new node. Okay, so let's do this. Let's create our new node right here, like this. Data link. There we go. We're going to create it. We're going to call the constructor on it. We're going to make it 0 and then point to null temporarily. I won't draw it, but we're going to point to null. OK, then we're going to set that link. This is the tricky part. Not tricky, but you got to think one level deeper. Right? It's like when you're playing chess. You got to think a couple levels deeper. You got to think a little deeper here. This is saying set the link of the new node that we just created, that, by the way, temp is now pointing to here, the new node. Set the link of what that's pointing to the link of the previous one, what it's pointing to. Why do we do that? So that we now can say this one is going here, because we're trying to insert this here. Okay? So set the link of what we're pointing to whatever the previous one was pointing to. This one is now pointing to here. So far, so good? All right. And then it says, set the data. All right, so we'll call it 6. Right? Set the data to 6. And then it says, set the previous link to that new, to point to that new link. Set the previous one to point here. Now, this looks a little crazy on the board, but let's see what we've got here and see if we've actually got a linked list. We have a head. The head is pointing here, the one we just inserted before. That one's pointing to this one. This one is now pointing to the one we just created, which is pointing to the one that was there before because we just inserted it in there, which is pointing to here, which is pointing to null. See how we insert something at a value that's not at the head of the list? Okay, you can see how that works. All right. Again, it looks a little crazy here. You might want to go home and draw it out yourself so you can follow this code and draw some things. It's a little hard to draw on the board like this. Okay? All right. And then there's a couple other ones here. We can insert nodes. We can also remove them. With an array, in order to remove a link or remove a value, you had to do a lot of moving around. Okay? You don't have to do that anymore. Okay? Watch how we actually go ahead and remove the node at the head, okay, right here. I'm going to get this temp one out of the way again. All right. This has to be a little clever as well, and you'll see this in a minute. Okay, first of all we need to pass is the node at the head, because that's the one we're trying to remove. We do have to pass a reference to the head, that little ampersand in the parameter there, because we're going to need to change the head to point to a new place, because we're getting rid of this first node. Okay? We're getting rid of that node. So create a temp. Set the temp directly equal to whatever the head is pointing to. So temp is going to point here. Now you think, why are we doing that? We're just about to delete it. What's the point of that? You'll see. Now we say, change the head to what it's pointing to. Because we're going to get rid of this one and make this the head. So now our head needs to point to the new value there. Okay? And then this one, if we had done that without this temporary thing, we wouldn't know how to delete this guy. It would just be kind of floating out there with nothing pointing to it, and that's bad. In some other languages, it's not terrible. But in C++, that's bad, because the compiler has no idea that you're not pointing there anymore. It's just wasted memory and actually what we call a memory leak if we didn't do that. But what we're going to do now is we're going to say, hey, delete the temp that we're now pointing to. In other words, don't delete temp itself. That's not what this means. What it means is delete whatever it's pointing at. That's this. We're going to delete this like that. By the way, is temp pointing anywhere now? It's actually, as far as I know, it's still pointing into nowhere land. I'm not sure if delete actually sets the pointer to point to null. I don't think it does. So you can't go and use this anymore. Once you've deleted it, don't try to use it anymore. That memory has actually been freed up. Okay? And then return the new head so that we know where the new head is. But we don't actually need to do that because we were able to actually change the value here. Okay? But now, have we deleted the link at the node at the front? Yes. Now we've got the head pointing to what's now our new head. Used to be our old one. Now it's new head. And the same list going on and on and on. Okay? All right. Last one I'm going to show you. Oh, and by the way, note the reference there. Last one. Well, we deleted a node at the head. Let's delete one somewhere in the middle. Okay? All right. Remove at node head. You know what? Don't pay no attention to that top line. It's the next one. I didn't replace that correctly. It should say remove at node previous, because we don't need the head now. Okay? Again, if we're going to remove, let's say we remove this node here, we don't need to know that node. We need to know the one before it. Why do we need to know the one before it? Because this node has no way of getting information from a previous node. Okay, so you need to know where the previous node is in order to delete this one. It's a little odd that way. Okay, but that's the way these singly linked lists go. Okay? Let's see what we do with this. All right, first of all, we're checking that it's not null. We wouldn't want to do that. Again, set up a temporary node. Set the temporary node to the previous link. Here's the one we're trying to delete, this one. Trying to remove that one. The previous link is where we're going to set our temp to. So it's also going to set there. And this is exactly the same reason we did it with the previous function, or previous method. Okay? All right. Then we're going to say previous set link, set the link to this, to our temporary one, which is what we just set the link to what it's pointing to. So set this link to this guy, because we're trying to remove the one in the middle. There we go. Now that's set to that guy. Okay? Now we still have a way to get back to that one we're deleting, so we can actually delete it. It is going to go away like that. And we're going to return previous just so we know where it is. I guess we don't even need to do that. Do we have a proper linked list? We've got a head pointing here. This one's missing now because we just deleted it. But it's got a pointer to here and there and pointing to null. And we've deleted it. Whew. OK? Questions? Yes?
It says delete temp, but shouldn't it be delete start temp? I don't know.
No, as it turns out, it's just delete temp, which means delete what it's pointing to. Delete takes a pointer and deletes that. As far as I know, it is. Pretty sure that's the way it is, yeah. Question? If it's not, I'll check.
Node start temp. Are you creating a new temp?
Yeah, in this case, in this method itself, you're creating temp, which is a pointer to a node. So again, it's going to create that little pointer, which we're now going to set equal to the link of the previous one. And that's how it's going to go. OK? All right. Yes, question?
So, like when you're using temp inside these, like remove and insert, it's not the same temp.
Good. Yes, very good question. The question was, hey, when you're inside these new methods, is it the same temporary variable we used before? No, it's a completely new one. Inside this new method, it's created new for this, and it's called temp just because I was always calling them temp. That's it. Yeah. Yeah, I was returning it just because a lot of times you return what the last thing you worked on was. I just did that. You don't have to return it in that case. OK, any other questions? Don't forget to go to lab. I will see you guys Wednesday.